Hey everyone, this is Darshan Santal. Welcome to this video on derivatives, continuation of our calculus series. It's been a while, but yeah, it's good to be back. Derivatives are much more interesting than limits, I found, because there's a little bit more to them, and it's a little bit more cogent. Limits are more abstract, derivatives are more cogent, and they're more applicable to real life in general. So in this video and the next one, I'm gonna go ahead and just sort of unearth what a derivative is. I'm gonna take a little bit of time on this because this is really important knowledge, especially if you plan to pursue math further, math and science, or if you just plan to go ahead and do the AP Calculus exam. This is pretty important for you, and also it just helps you do the problems that we're gonna do in later videos better and sort of really understand where they're coming from. And also, it's a pretty cool concept. You will probably want to know it anyways. So let's go ahead and get started then, shall we? So let's just go ahead and talk about rates of change. So what are rates of change? Well, rates of change, this should be a review for you, but rates of change are just a change in something as time passes. Now, one little thing I want to add here is that time may not directly be presented here. Like, for example, if you had a soccer stat that said your player scores 5 goals every game, which is pretty brilliant, but you know what I mean, then the number of games is not a direct unit of time per se, but it's a sort of duration. It represents a certain duration. So rates of change nearly always are associated with time. And sometimes it's not even a direct unit of time, but more often than not, you'll have some kind of time in there. And for the purpose of this video, we're going to be mostly using time. And what are some examples of rates of change? Well, let's take a look. Velocity, it's always a good one to know. This is displacement over time. You'll probably see this a lot if you do physics or even chemistry possibly, and that's going to be meters per second. Okay, and another good one that's more relevant to all of us today is internet speed. So this is the rate of data transfer. This is usually seen in Mbps, or megabits per second, and this is basically the rate of data transfer between your computer and the server, both back and front. That's kind of what that is. And another thing that rate of change represents a rate of change, and you may not see this directly, but is the slope of a line. So for example, you may not see this directly, but let me just show you how this works. So let's take our slope formula, which is m equals delta y over delta x, or y minus y1, but you get this, it's the same thing really. This basically represents how y changes with respect to x. So really it is a form of rate of change. You'll probably see this if you've done a lot of problems with this in algebra. You'll see rate of change and this kind of used interchangeably, but you get the idea. A slope is a kind of rate of change, just not in the way you might see it in the real world. Okay, so that's what rates of change are. So now let's do a little bit of practice. So I recommend you just go ahead and pause the video and do these on your own. They shouldn't take you more than maybe a minute or so, because they're pretty basic problems. So you could pause the video right now, do them, and I can then resume and we'll go over the answers. Okay, let's go over. So let's go ahead and talk about the first one. So Virat Kohli scored 973 runs in the 16 innings he batted during the 2016 IPL, which is a cricket tournament. So how many runs did he score per innings on average? Well, let's take this out a bit. So average would equal total runs scored over number of innings, which is going to be 973 over 16, which is equal to 60.81. And don't forget the units, which is runs per innings. Okay, so I know I went a bit fast, but you know these are pretty easy problems. You should probably know them anyways. So that's number one. Number two, a car travels 300 kilometers in 5 hours. What's the car's average speed for these 5 hours? So again, average equals total distance. So I'm writing this all out just so that if you made a mistake, you can kind of see where I'm getting everything from, so you can find out where you went wrong. Total distance over time, which is going to be 300 over 5, which gives us 60 kilometers per hour. or kmph. Here's what I see it as. Last one is calculate the slope of a graph between the points 0, 1 and 2, 5. So let's write this out. So m equals y minus y1 over x minus x1, which would be 5 minus 1 over 2 minus 0, which is 4 over 2, which is just going to be 2. And there's really no units associated with that because we're not given anything in the first place. Okay, so if you got any of these wrong, it's probably just a simple mistake. Just go back and check what you did. Or if you really don't understand it, I have a couple of videos that you could watch on these kind of linear equations and rates of change. You probably just need a little breather. But either way, I hope this was a good refresher on just these things, because you're going to have to do a lot of rate of change problems as you go into calculus. It's just a little bit more complicating. So yeah, I hope you understood that, and let's keep moving. So what does this mean exactly? So let's make sure we understand what exactly this means. So all these rates are averages. You might have noticed I said the word average, runs per innings, average rate of change. I just didn't say average for the last one, but you know what I mean. So all these rates are averages. So what do we mean by that? Well, they're reflective of the overall change between 2 points. So what that exactly means is that they don't reflect everything that happens in between them directly. So it's more of a sum of everything that happens. So for example, like consider your car example. Like the car is going, just because the rate that we calculate is 60 kilometers per hour, that doesn't mean that the car is always going at 60 kilometers per hour for the entire duration of the trip. That's just how fast it's going on average. So for example, if you were caught speeding, or if you're caught speeding here, then the cop would pull you over only if you crossed 80 kilometers per hour for that instant. You can't tell him that you traveled 300 kilometers over the span of 5 hours, and so that therefore your rate is 60 kilometers per hour. You went over 80 at that particular instant, which is why you get the ticket. So like I said, it does not reflect everything that happens. So let me show you some other data to back this up. So for example, consider Virat Kohli's stats in 2016 IPL. So if you just notice here how he's not scored 60 runs every innings, obviously. So there's a whole mix of numbers here. And eventually, if you take the average of all this, yes, it comes around to around 60.81, and that's the answer that we got. So, but it does not reflect it does not tell us that he is going at 60 runs every innings. So there's a mix here. So I hope you're getting the picture of what exactly happened, what we're talking about. The average does not tell us what happens in between. All it tells us is that, okay, so this is how much he's done on average. This is the overall amount that he's done over this stretch of time. So consider this graph. Like I know the slope, this blue line represents the slope here, and that slope would be 2, but what if the graph looked like this green line over here? Well, that also goes between these 2 points, and the average slope of the graph between those 2 points, yes, it is 2, but the graph itself never has a slope of 2 never has a slope of 2 anywhere on this interval. So I hope you get like I said, I just hope you get the picture of what's going on here. It's just that the average is not reflective of what happens at each instant. Alright, so let's go ahead and review. So the rates we calculate using our slope formula are averages. We talked about this throughout. It does not have to reflect what happens at each instant of time. So for example, we saw many examples of this. We saw the car, we saw with the bathroom Virat Kohli's stats, and we even saw with the line. The slope does reflect the overall change, but it is not reflected what happens at each instant. Now the question I'm going to leave you with this. Can we use math? Can we calculate rates of change at each instant of time? Can we actually figure out what happened at each instant of time? Well, that's the question I'm going to leave you with, and we're going to talk about that more in the next video. So thank you for watching. Hope you found this helpful, and see you next time.